Assalamu alaikum everyone. So continuing with our lecture on contouring. So the next definition that we are looking at is horizontal equivalent, and this is something that we have discussed before. Horizontal equivalent is the horizontal distance between two contours, and when the ground is steep, the contours tend to come closer, and therefore the horizontal equivalent decreases. Whereas a flat or gently sloping ground will have widely spaced contours, which means that the horizontal equivalent is large. So that means that when the ground is plain, the elevation does not change quickly, and you draw contours for specific contour interval which is pre-decided. So that means if I am drawing a contour map for a contour interval of 10 meters and I drew one contour at 90 meters, then the 80 meters would be pretty far away because the land is pretty flat. Whereas if the land is sloping, so that means after 90, 80 would come very quickly. So that means the distance between two consecutive contours decreases when the land is steeper, like in this case, and you can see the contours are very closely spaced, and where the ground is having a mild slope or gentle slope, that means the distance between successive contours increases. And like I explained before, this is because the contour interval is pre-decided, and that basically determines the distance between successive contours. That doesn't mean it will always be very far apart, the contours will be far apart. If you take up a contour interval which is very small, let's say 1 meters, then it means they will be pretty closely spaced lines. But since the contour interval is so small, the lines would be even closer on the other side where the land is steep. So this is everything that we have discussed up till now. So let's see this figure. So we have this sort of a topography where we have three peaks in this mountain region. And when you draw the contours, so we have this peak which is the highest, and we have this one and this one. And when you draw the contours, you'll have three set of uh, concentric irregular circles. And if you go beyond them, you'll have these bigger circles which join all the three hills, the base. Since the peak is right at the top, if you go a little bit down, then the land is such that the same elevation is available on all the peaks. So you get lines which look something like this. And if you don't have this, like if you're watching it from the top, it's a satellite image, then you won't be able to decipher that you have three distinct hills. But once you have the contour map, which is also from the top, but just by looking at the map, you'll know either you have three valleys or you have three hills. And if you write down the index contours or the contour values along with the map, then you quickly get an idea what the land is basically. So like we see over here, so we have two hills, and when you draw the contours, so the contours, these hills are shown in a section view. That means you're looking at them from the front in actual. So they'll have like a conical shape, and that's why you have a contour which is circular, and two hills, so that's why two set of circles, and then you have bigger irregular circles since the elevation then gets similar with both the hills. Something that we've discussed so many times, that when you have steep slopes, the contours will be closer, and when the land is flatter, that means the contours will be widely spaced, and you can have these empty spaces in between. That means that the land probably over here is of such elevation whose contour line you decided not to draw. So, and that basically means that the land is pretty much flatter. So you get an idea. And another thing to see is that some contour lines are bolder. So we talked about this. These are called as index contours, the contours on which you mark down the elevations. And then the contour lines between two index contours have elevations midway. And depending on what is the difference between the two index contours and how many lines do you have, you can find out the contour interval, which is the difference in elevation between two successive contour lines. So another contour map over here. You see this grid. these dotted lines and they make these perfect squares. We'll talk about them in a bit, but let's just first visualize this contour map. So you have a contour map on which we have contour lines which are 850, 852, 854, and 860. So that means that whatever land this is, it is at highest elevation at this point or in this area. So this is basically a whole area of the land. And let's imagine this is a grid which represents 1 kilometer by 1 kilometer. So this land is 1 kilometer square, right? And similarly, you can have one, two, three, four, five boxes, and this total is, let's say, 1 kilometer. That means this is zero point 0.2. So this makes zero point 0.2, zero point 0.4, zero point 0.6, zero point 0.8, and 1. So this smaller square would become of 0.2 into 0.2 kilometers. So this is basically area on the land, and you're looking at it from the top, and the north is in that direction. So the highest contour is over here, 860. That means that the land is steepest in this area. Then the steepness keeps on decreasing as you move down. And what's another distinguishing feature on the map is this line over here. This line is actually showing you there's a probably a stream or a river or something, but usually you don't have these on the map, so you just have this distinct shape over here, and these shapes that successive contours are making. So this line, like we discussed before, represents a valley line. So you have these distinct V shapes inverted, and over here, this represents a ridge line, because as you can see that the elevation keeps on decreasing on successive contours, and every contour has a distinct shape that has this U shaped at the center, and they coincide basically. So whenever you get a shape like this, that means it's a ridge line. And we discussed before what is a ridge line. Ridge line is the top of a mountain peak, or it is in continuation in this case. So you have a peak that has a decreasing elevation as you move down, but it's a sort in which if you're standing at the top and you keep walking in this direction, so the elevation would keep on increasing in a straight line. And if you go to the left, then the elevation decreases, and if you go to the right, it decreases, and if you come back, it decreases as well. So this represents a ridge line, and this over here represents a valley line. So if you get these shapes on your contour map, you can distinctly tell what they represent. So like this over here, two V shapes. So that means we have two valley lines, and in the center we have the other shapes, and which are not that much steeper like we have in a valley line. So milder shapes and successive ones, they represent a ridge line, which is a mountain top, and over here you have a depression, which is a valley. So now that we have understood what contour maps represent and what information you can gather out of them, what are the properties of the contour lines and everything, now it's time to see how can you prepare these contour maps or topographic maps. So we have a number of ways. Basically, the information at the end that we require is both horizontal control and the vertical control. Because one, this is a map that shows elevation differences, and that means you need to find out reduced levels. And secondly, since uh, the reduced levels that you calculate are at a distinct location, and the contour map tells you which point is at what elevation, that means in addition to the vertical control, you need to have horizontal control. So you need to know at what area or at what location in the XY plane is that point whose elevation is this much. So you need both the horizontal control and the vertical control. So that means whatever method that we have studied before for finding out distances, for angles, and for reduced levels, all of those methods would come in. So we have to first use leveling methods for gaining vertical control, and then we have plane table method, that is basically a method that allows you to find out location of different points with respect to some reference. And then we have tachyometric method, in which we find out distances from any reference point. And then we have photogrammetric method, in which we can again take photographs and do the same thing. But the important thing is that we need to locate contours. So we need to know at which location what is the elevation. So for locating the tours, both horizontal and vertical control is required, like discussed, and horizontal control depends on extent of areas and accuracy required. So for small areas, chain surveying and offsets from survey lines or plane table traverse is applicable, and for precise work, theodolite traversing is better. In addition to tachyometry, so you can get angles with the theodolite, and using a tachyometer, you can find out distances. So that makes the whole process more precise. And for vertical elevation, leveling is the most common method that is used. But in nowadays, you have GPS devices that can do both, find out coordinates in terms of latitude, longitude, and altitude, so they can work very faster. And then we have some more modern methods of remote sensing, which can do all of this, give you elevation models using lasers and other techniques, and we'll discuss them in the next semester. But let's see how we can do the same thing using the instruments that we have. So for that, we have two methods: direct method and indirect method. So the difference between the direct method and the indirect method is that in direct method, you first decide um, what are the contours that you are going to draw for what elevations, and then you actually try to find out the locations on the ground that have that specific elevation. Whereas in indirect method, you make a grid like we had before. So you divide your land into these smaller squares, and at every intersection of these lines, you determine what is the reduced level of that point. So these numbers in inclination, they show that what is the reduced level at these points. And then what we assume is that if the reduced level is 848.20 at this point and 848.54 at this point, it increases in or decreases in a linear manner. So it uniformly increases or decreases along this line. So let's say if I am drawing I have these 2 points, 849.20 and 854.63, and I want to draw a contour for 850. So 850 would be closer to 849, so it will be somewhere over here. And we'll discuss how do you find that. So that is how you trace out the points with the elevation that is required, and then you draw the contours. And in the other method, if I want to draw a contour for 856, that means on the ground I need to find out the locations where the elevation is this much, and then the contour is drawn automatically. But this process is really tedious, so therefore, usually we use the indirect method. So, like we discussed in the direct method, that the contour is actually traced on the ground. So you try to find out the locations which have a specific reduced level, the reduced level for which you are drawing the contour. So, for example, if the height of the instrument with the leveling instrument is 201.45 meters, and the contour of reduced level 200 meters is to be determined. So that means you're trying to trace or locate points that have elevation of 200 on the ground. And in any setting of your instrument, wherever your instrument is, the height of instrument is 201.45. So that means you'll take your staff to different locations, and the person looking through the telescope is actually trying to find out the location of the staff where he gets a reading of exactly 1.45, because when you subtract that reading from the height of the instrument, it means that the reduced level of that particular point is 200. And you can imagine how tedious it would get. So it gets very hard when you want to do it on a larger scale, but this is how it's done. And once you do it, so obviously wherever the level stuff is, where you get that specific reading, so you take its location using a theodolite or measuring tape. So you pinpoint the location of that point, and then you have it. You have the vertical control as well as the horizontal control. But then we have the indirect method of contouring, in which you draw a grid, and then you try to find out reduced levels at the intersection points. Or you don't have to draw a grid. You can do it by method of cross sections or by radial line methods, different methods. But the most common one is the grid method or the method of squares, where you find out contours at predetermined points, so points whose location is predetermined, and then by interpolation you can find out other reduced levels, so reduced levels for the specific contour that you want to draw. So like we have over here, first you draw a grid, and the grid would have a specific size, and this the whole of the grid would cover the whole area that for which you want to draw the contour map. And then you divide it into smaller grids depending on how accurate you want your work to be. And then at the intersection points, at these specific locations on the ground, you find out reduced levels. And once you have these numbers at the intersection points, then you see that what is the highest value on the total grid and what is the smallest value. That means you would know in what range will the contours be. And then you can select the minimum value of contour that you want to draw and the maximum value, and then decide upon a specific contour interval. So in this case, the highest value is 102.8, and the lowest value I think is 98.5. Yeah. So that means my smallest contour will be greater than 98.5, and the biggest contour would be smaller than 102.8. So in this case, they have chosen the biggest one as 102, and they have chosen contour interval of 1, because this is 102 and this is 101. So this would be 100 and this would be 99. So once you have chosen these values, then it depends on you to trace out on the entire map where that value could be. So let's say I'm trying to draw a contour for 102. Let's start from here. Now, if you look at these, over here the value is 98.6, over here is 98.8. That means no value between them will be 102. Similarly, on this entire area, there's no point whose elevation would be 102. But if you come over here, I have 101.1 over here and 102.6 over here. So that means, and there should be a value over here. I don't know what the value is, but let's assume that it is 101.5. Let's say, and the value over here is 102.6. That means 102 lies somewhere on this line. And by interpolation, by linear distance, let's say if this is uh, on your scale on your paper, if this is, let's say, 3 centimeters, and I can find out the difference between 102.6 minus 101.5. So you can divide that into 3 centimeters, and you could get that how much elevation you get by moving 1 centimeter or 1 millimeter on this line. And that way you can trace where 102 lies. Similarly, on all the other lines, you trace out where that value of 102 is. And once you have points on different lines, then you draw them or join them by a freehand. So you don't draw contours by straight lines, you draw this by a freehand. And similarly, if you want to draw contours for 99, so you see where the value of 99 would lie, and on all those lines you trace out where 99 is, and then you join those points by again a freehand. So this is how the grid method works, and you draw out contours. So similarly over here, first, when you've done the survey in the ground, you choose a suitable scale for your grid to be drawn on paper or on your software. And once you have that scale, you draw it on your paper, and you mark the values on the specific grid lines. So the grids would be drawn according to scale, but these values would remain as they were in the field. And then you see what's the minimum value, what's the maximum value, then you decide upon the contour interval, then you start drawing the contours from the smallest value. So let's see over here, they are drawing for 98. This value is 97.6 and this is 99.25. So if this distance is 5 centimeters, so that would mean 99.25 minus 97.6 divided by 5. That would give me what is the elevation difference if I move 1 centimeter on this line. Obviously, this is smaller, this is larger, So as I move 1 centimeter over here, how much increased would the elevation be at this point? And by doing this, you can find out where should be 98. Then you mark that point on the line, and then you draw them by a freehand. So this is how interpolation works, and this is a very quick method or a very easy method to plot contours. So that was it for the lecture, and I'll see you in the online lecture.